Imagine shrinking down until an entire world fits inside a grain of dust. Welcome to the realm of atoms, tiny building blocks of everything you see, touch, and breathe, yet so small that millions could fit on a pinhead. To picture a simple atom model, think of a bright central sphere called the nucleus. It holds nearly all the atom's mass, made of two kinds of particles, positively charged protons and neutral neutrons. Now imagine an invisible playground of energy around that nucleus. In our simple model, this space is divided into shells or layers, like seats in a tiny theater where electrons are allowed to move and dance. Electrons are extremely light, negatively charged particles that stay in constant motion. Instead of tiny planets, you can see them as fast-moving glowing dots, zipping through those shells at incredible speeds. Opposite charges attract, so electrons are pulled toward the positive nucleus, yet their motion keeps them from falling in. This balance between attraction and motion is what keeps the atom stable and intact. In this simple model, the number of protons in the nucleus sets the atom's identity, while the number of electrons around it sets how it behaves in reactions, forming new substances by sharing or trading electrons. Even though real atoms are more complex clouds of probability than neat orbits, this basic picture helps us imagine structure: a dense center, layered energy zones, and speedy electrons shaping every bit of matter. From the air you inhale to the water you drink, all matter is made from these structured atoms. By understanding this simple model, you unlock the first step to exploring chemistry, stars, and the universe itself.